In this lesson, we're going to look at surface areas of prisms and cylinders. Remember what a prism is. It's a polyhedron with two congruent faces called bases that lie in parallel planes. The other faces are called lateral faces, and there always will be parallelograms formed by connecting corresponding vertices of the bases. So I have the number of lateral faces as the number of sides of the base. So if I have a pentagonal prism, then I'll have 5 lateral faces in 2 bases. The segments connecting these vertices are called the lateral edges. Surface area is the sum of all the areas of its faces. That includes the bases and all of the lateral faces. The lateral area is just all of those lateral faces combined. We can think of this in terms of what we call a net. A net is a two-dimensional representation of the faces of a polyhedron. If you can imagine cutting along the edges of the polyhedron and unfolding it to make it a flat surface. So, drawing nets. What I have is this one is a triangular prism. Remember that it's made up of 2 bases, so I'm going to have 2 triangles, and it's made up of 3 parallelograms, in this case rectangles. And so when I think of unfolding this and how it would look, what I would have is there would be one of the lateral faces, rectangular shape. There is the other one, and there is the third one. And then I would have a triangle on top, and I would have a triangle on bottom. So that is where the net would look like. Now these triangles may be here, or they can be in different places. It doesn't matter, as long as you're showing all of the sides and all of the faces. For a prism, remember I've got 4 sides, a top and a bottom. They are all squares, so 1, 2, 3, there's my 4 sides laid out, and I will have a top and a bottom. In this one, I have pentagons. So I've got a pentagon at the top, and that's not a very good drawing of a pentagon, but you can see what I've got. And remember, I'm going to have parallelograms, 1 for each side. So there's going to be 5 of them, since that is a pentagon. And then I'm going to have another pentagon on the bottom. My drawings aren't real pretty, but you can see what I mean. A right prism is a prism where each of the lateral edges is perpendicular to the bases. So when the sides are perpendicular to the bases, then what we have is a right prism. Excuse me. The height is perpendicular distance between the bases. In an oblique prism, it's when the lateral edges are not perpendicular, but still the height is still the perpendicular distance between the bases. Surface area of a right prism. What if I think about unfolding this into my net, where here is my height, and this red line here, or the length, or all 3 of these lateral sides added together, would actually give me the perimeter around that triangle. So that would be the perimeter. So the surface area of a right prism is the sum of the base areas and the lateral area. My base, capital B, is the area of the base, P is the perimeter, and H is the height. Now here's what I want you to think about. I could find one of those sides and multiply it times 3, or I can realize that these 3 are going to make a rectangle whose height is the height of the prism and whose length is the distance around the base, or that triangle, because it's just made up of those 3 sides of the triangle. So I can use my perimeter as somewhat of a shortcut. So surface area is 2 bases plus the perimeter times the height. Sometimes you'll see that written as 2 bases plus the lateral area. find the surface area of this right pentagonal prism. Okay, notice what I've got. I've got that the pentagon has a radius. Remember, we get our radius from the center to a vertex on the pentagon. Radius of 6 feet. The sides of the pentagon are 7.05 feet, and the prism has a height of 9 feet. So I'm going to find the area of one of the bases. Remember how we would do that in a pentagonal prism. I would first find my apothem, which would be this length right here. This is the apothem. I'll use this right triangle to do it, and since this length is half of that one, that is half of 7.05 is 3.525, and therefore my apothem is the square root of the hypotenuse squared minus the leg squared. And in this case, it comes out to be about 4.86 feet. My perimeter is simply 5 times the length of the side, so 5 times 7.05. So my base area, remember, is 1/2 the apothem times the perimeter. So I plug in my numbers, and it comes out to be approximately 85.66. So my lateral area, that's my perimeter times my height. The perimeter we already found to be 35.25, and the height is 9, so that comes out to be 317. So my surface area is 2 times my base plus my lateral area, so I plug in and get my entire surface area, in this case about 488.57. So here's the ones for you to try. Draw a net of a hexagonal prism. So remember, I need a hexagon. That will be 6 sides. So 1, 2, 3, 4, 5, 6. I need 6 of the parallelograms, which will make up the rectangular area here, and then I have to have another hexagon. So there is my net of a hexagon. Find the lateral area and surface area of a right rectangular prism with a height of 7, a length of 3, and a width of 4. Okay, let me see if I can draw this. I've got this. Here is going to be my height. So my height is 7, length of 3, width of 4. So my lateral area, remember that's of the sides. What I've got is the distance around this is 3 plus 4 plus another 3 plus another 4, so that is 14. So my perimeter is 14. So I needed to have that. And then multiply that times the height. So perimeter, so the lateral area is 14 times 7, which is 98 square inches. And then my surface area is twice the base. So now what's my base? The base is this right here. So the base is 4 times 3, which is simply 12. I need 2 of those, and then I need the lateral area, which we found earlier, so it comes out to be about 122 square inches. A cylinder. Remember, a cylinder is like a can. It's a solid with circular bases that lie in parallel planes. The height is a perpendicular distance. The radius of the base is the radius of the cylinder. In a right cylinder, the segment joining the centers of the bases is perpendicular to the bases. And so that would give us our height. If we were to slice open a cylinder to make a net, you can see that this lateral area actually comes out to be a rectangle whose length is, this length here is the same as the distance around the circle, so it's the circumference of the circle, and the width is simply the height here. So if I want my surface area, I need the 2 circles, and I need the rectangle made by the circumference times the height. So that gives us our formula for the area of a right cylinder. it is 2 bases plus the circumference times the height. Or if you want to go ahead and plug in the formula for the area of your base, it'd be 2 of these pi r square, which is the area of a base, and 2 pi r is the circumference times the height. So in this case, we would find the area of the base, and then we would get the area of the side by doing 2 pi r circumference times height. So you're wrapping a stack of 20 compact discs using shrink wrap. Each disc is cylindrical, so we got a cylinder with a height of 1.2 centimeters and a radius of 60. What's the maximum amount of shrink wrap needed? Okay, so we got these. Remember, what I'm doing is I'm taking these and stacking them up so that I end up with a stack of CDs here. The discs are stacked, so the height is 20 times 1.2 or 24 millimeters, and the radius is 60. So I'm going to use my 2 times the area of the base plus the circumference here, circumference times height. This is 2b plus the circumference times the height. So simply plug in and work it out, and you find out that it's approximately 31.666, and that would be millimeters cubed. So find the height of a right cylinder, which tells me my surface area. Oh, I'm going to have to use my formula again, substitute in everything, and then solve for h. So this is twice my base plus circumference times height. Once again, just using the formula for the area of the base and for the circumference, plugging in my numbers, and then that's a matter of solving this equation for h. So I will simplify this down to be 12.5 pi, subtract that from the other side in order to get 5 pi h by itself, and then divide both sides by 5 pi, and that gives me my h. So here's one for you to try. Find the surface area for right cylinder with a height of 18 centimeters and a radius of 10. I want to come over here and see what that looks like. I've got a height of 18 and my radius is 10. So remember what I need. I need the area of that base. So I'm going to need pi r square. So pi times 10 squares, 100 pi. And I need 2 of those. And then I need the circumference, which is twice the diameter, or 2 pi r. So that's going to be 20 pi. And then multiply that times 18. And that will give me 1,759.29 centimeters squared. The radius, find the radius of a right cylinder with a height of 5 feet and a surface area of 205. Remember, I'm going to use my twice base. My surface area is equal to twice the base plus the circumference times the height. So in this case, this is 2 times pi r square, and that's times 2 pi r times h. Now, let's plug in what we know. 208 pi is equal to 2 pi times r squared plus 2 pi r times h, so that's going to be 10 pi r. Notice that we've got r squared and r, so we're going to need to set this equal to 0. R squared plus 10 pi r plus 208 pi. I need to use my calculator or factor this. I think it would be a lot easier if I get 2 pi out of the way. I'm left with r squared plus 5r plus 104, and then if I divide by 2 pi, then that cancels out, and so I can say this equal to 0. If I plug into my calculator and find my zeros, I will see that the radius